first I want to welcome you to BazelCon 2020, acknowledging that we are definitely in a unique time in the world, and we've obviously had to conduct a virtual conference as opposed to a physical conference this time. I'm still really excited about the amount of material we have and the interactive sessions we're going to have, and I'm really happy that you are all participating. And I think it'll be a great conference. I want to remind you that, like every single past BazelCon conference, we have a code of conduct that's published on our BazelCon website. For social media posts, please use the hashtag or the BazelCon hashtag on Twitter. And for attendee networking, please join the hashtag BazelCon 2020 channel on the Bazel Slack site to chat with other attendees, and use the hashtag BazelCon 2020-announcements for official announcements. So I want to start off this talk by giving you a bit of Bazel history. I've been a part of the Bazel journey since its start. I actually started managing the build tools team at Google back in 2010. And it was in 2014 that we as an organization decided we were going to open source Bazel. And to really give context for Bazel and its path, it's important to go back and understand some of Google's key development principles, which have been around.
Screw it. Now let's go to Hacker News. I was going to watch that BazelCon intro, but honestly, I'm not really feeling it. It's just a little too slow for me. I think I'll watch it later. Let's see. Thought this one's pretty good. The myth of self-documented code. Yeah, the overall idea is that with good variable names and code organization that you don't need comments. But there is the fallacy of human judgment here. The reason why is because, well, things that are obvious to you aren't obvious to other people, because the code actually lives within a greater ecosystem, right? And so because of that, you do need to have that global context. Now, this also means that with people who read the code, you're talking about like appealing to an audience who has not read your code before. But in general, the most people who are reading your code probably have read stuff that is tangential to it before. So you actually do have some translucent context into it. And so the point they try to make here is that, yeah, you break encapsulation if you try to just jam more of the overall context into the code that you write. So, for example, you can embed some of this information in the variable and function names, but you're only going to get one slug per thing, which lets you encode small, distinct concepts. You could try encoding more by breaking a function, but then you're making the code harder to follow. Yeah. So it's like trying to follow the trying to follow that concept. The more you break up something, the less readable it becomes. But it does operate as an individual unit. Now, how these individual units play together is going to be the issue. Yeah, and then comment why not what, but there's a huge class of information behind why. Yeah. Most people don't even realize that they can document that stuff. Yeah, I mean, like, why would you write something in a code rather than like an eng wiki that just explains something at a high level? So, it does get a little bit weird when you actually start digging into the these heuristics. So the difference between tactics and operation. I think this is a pretty good section that they talk about in this blog. Like I said before, but operational information is more global, how the code fits within the larger program. But tactically is the code. So when they say tactical versus operations is just like how the code works in the greater ecosystem, and tactically is how you write that individual unit. And so they give this like simple example where it's like, yeah, if you don't parse the args, run usage, build and send requests, check response. Otherwise, if it's okay, then exit. This is all pretty reasonable and easy to read, but then when you actually dig into it, you'll see like build and send request, performance HTTP request, and then builder.send. So you have to actually dig into a lot of layers before you can even get to the nitty-gritty units of what you want. And at each level, you essentially have to try and piece together the context yourself. And that can actually lend itself to a lot of weird situations, especially if you're a new person reading the code. So what's obvious to you might not be obvious to everyone else. And I think I've actually ran into this problem myself when I was working on a code base. Like back at Apple, I understood how all these different UI and back logic actually worked. But it was really hard to communicate that and communicate the decisions of why we made certain design choices other than we ran out of time. And so this like it's human. It boils down to human judgment, and human judgment is very fallible. But yeah, this guy, I think he just like writes a lot of criticism, but he doesn't actually write like a good alternative. I think it's more this blog should be read more as a hey, yeah, there is a flaw to this self-documented code heuristic. So I think he does make some good points here. And I think that if you really want to dig into how this actually causes issues, it's like it just basically means that if you assume self-documented code, then you assume that the developer has a good amount of context that he doesn't need to read the code itself. So it kind of ends up being self defeating actually in that regard. So you would have, if you believe in this self-commenting thing, you believe in 100% tactical effectiveness, which is never the case. You know, otherwise we would never have bugs. So I think this is a good blog to read, just as a reminder that not every single heuristic in coding and software engineering is going to apply. Let's see what else is out in Hacker News. Oh yeah, the Apple announcements. Huh. Next generation of AirPods. I mean, I already have the Pro. Apple announced that their third generation of AirPods. Honestly, like spatial audio features. The only thing I think people care about is the battery life, to be honest. And the battery life on the AirPods Pro is actually pretty good. So, I don't see myself getting this, but I fucking love their products, man. Okay, AirPods. Okay, I see. AirPods third generation is $179. I mean, I got the $249 one, but oh boy, I love how they put the pricing like in really tiny font here. So, but yeah, I honestly think that if your company like subsidizes it, you should get yourself a pair of AirPods. They're actually pretty good. What? Apple launches the world's best cloth? The fuck? What? They made a polishing cloth. What? Why would I pay $19 for this? Are you kidding me? Why would I buy this? Like, I mean, I can just go to a freaking like Best Buy and get a microfiber cloth. I'm like, what? What? All right, whatever, man. Okay, so I got so he's gonna show up in 5 minutes. Yeah, so for people who are just joining me, welcome. My name is Edbert. I am a senior software engineer, an ex-Apple senior software engineer, and I help people ace the coding interview. We will have our client show up at 8 p.m. But yeah, this 5 minutes before then is a open floor. Ask me any questions you'd like about like the coding interview, engineering in general. Yeah, I'll be happy to answer all of them. The wealthiest 10% of Americans own a record of 89% of all U.S. stocks. Is that by market cap or by number of stocks? Oh, yeah, it's all by market cap. Over 6.5 trillion. Blah blah blah. Yeah, I guess if you want to actually invest off of this, just invest in luxury brands, really, because it's just a what's it called? There's just a trend towards economic inequality anyway. So. Younger investors brought in compared to what? Yeah, many younger investors bought at a higher price, of course. Stocks only go up, right? All right, let's see what else we got here. How do you prevent SQL injection vulnerabilities? Well, SQL injection vulnerabilities just comes from adding a SQL query in the URL bar, right? If I just added a ampersand select star from ABC, see, then essentially when reading this string, then this would actually perform the SQL injection because it would pick up on this as if it was a actual command, right? So the one best practice is to really just sanitize the string. Don't actually try to run the what's called string as is. You could do like you could do a parse of the conditions and parameters. Another way is to God, I used to know this one. Yeah, I think it just mostly boils down to sanitizing the string that you use in the URL. God, I feel like there should be other ones, but I totally forgot them. Yeah, I guess also special characters maybe, and yeah, I guess and validating user input, which kind of goes along to sanitizing the string, right? Yeah. Maybe some weird procedure in your database, like maybe also limiting permissions there, so that way people aren't like dropping tables in production. So yeah, I think like also having limiting permissions on the database in order to prevent a lot of the blast radius and minimizing impact. Leave no trace. How teenage hacker? What? Okay, what the fuck did he do? Is being a developer a better long-term bet than being a white hat? It's hard to say because I don't really have too much expertise in the white hat hacking area. White hat hacking in general is usually like pen test, and you're usually hired by companies to try and break in to like their security in one way or another. But that also means that you command your own prices depending on how good you are. I would believe that. I personally believe that if you want to start your own business, then white hat is really the best way to go. Because if you end up being like a contract developer, then you actually end up in a very weird situation where you're responsible for your own learning. So, for instance, if someone comes to you and says, "Hey, I need a backend engineer," and you say, "Oh, I'm only mobile," then you're kind of fucked on opportunities. But if you can take the time to actually learn all the new technologies that are coming out and manipulate them and work with them, then you become relevant. And so, contract development actually is more or less a race to get ahead of the curve. So I would say I don't know if being a developer is a better long-term bet. You definitely have more options and stability, but I think in terms of like total compensation, I think that white hat would probably beat it out pretty handily. Shruby says it'd be cool if you could do a mock interview as an interviewee than as an interviewer. Yeah, yeah. I think I do. I think I do a few problem solving stuff to make up for that. But yeah, I'll let you know if that ever happens. I think it's a good idea though. Like I will be the first one to say I'm not 100% perfect. That I still make my own mistakes as well. But for the most part, I think that if people really get value out of it, then it's all good. So, okay, let me actually message the guy. I think I kind of messed up something here. Okay.
Recording in progress.
Hey, Edbert.
Hey, what's up, man?
I was able to join for some reason. It was like
preventing me from joining. But yeah,
It's all
all
good.
good now.
Yeah. Welcome to the stream. How you doing?
I'm doing good. Had a busy day at work. How about you?
Me too. It's kind of tiring for me. Yeah. So, like, I guess give people a little bit of context of, like, well, leaving out any personal information, like who you are,
Yeah.
what you're hoping to do here, and like, because we're gonna be working with each other for like the next few weeks, like what you're
Yeah.
hoping to get out of the coaching sessions with me.
Sure. So I'm currently a contractor at Facebook. My position is a software engineer, but essentially I'm a contractor at Facebook, and this is my first job out of college. And it's been about a year since I started working at Facebook, and I've been in the talks with my manager, and my manager and my peers have been pretty supportive in terms of getting me a conversion interview. But that's going to be for L4, and I'm hoping to prepare for that. And at the same time, I'm also in touch with a Google recruiter. Was talking to her today, and she's probably going to schedule my phone screen the second week of November. I'm also talking to an Amazon recruiter right now. Hopefully she will get back to me tomorrow. She was saying like if I'm comfortable with starting a new job in 8 weeks, but I'm kind of pushing back on that. So we'll see what she says when she gets back to me. But for Amazon and Google, those are going to be L4, L3. Facebook is going to be for L4. But those are the only ones that I'm looking at right now. I may potentially apply for more in the meantime, but yeah, that's pretty much the gist of it. And I'm just hoping to kind of brush up my coding skills as well as like system design for the L4 interview at Facebook. But yeah, that's about it.
Okay. So just to recap, you're aiming for L3 Google, L4 Facebook, correct?
Yeah, and Amazon is more like I'm just doing it as practice because I am not that interested in working there, but it wouldn't hurt to use it as a practice.
Okay, because sorry, go ahead.
No, that was it.
I was gonna say like okay, use Amazon practice. Because I was gonna say like if you're comfortable with the L4 conversion, then it might be worth your time to ask other companies to see if you can try hitting the L4 interview. But I do understand the limitation of what's it called, the 1 year of experience. But I think that if you did the interview and you got good marks, you could try to ask them to test you as an L4, like especially Google. But yeah, let's handle one thing at a time first. Let's go for the L3. Let's ace those, and then let's ask the recruiter if based on the results that you could test on it as an L4.
Okay, sure. Yeah, for now, like mainly because I'm not very confident in like system design. Like I'm just more going for L3, but yeah, we can see how those go.
Okay, yeah. And believe me, like once you like work with me for a while, you'll understand like why a lot of people get like really good results. And I'm pretty confident as long as you put in the work, you will get there. So I guess with that, let's actually go ahead and get started with the coding portion.
Okay.
Now you did say that I think that you rated yourself I want to say a 2 or like a 3.
In system design, yeah.
No, but what about like coding wise? Like the for coding.
It was like 6.5 over 10. That's what you asked,
Oh,
right?
yeah. I was also I meant it out of like a scale of 1 to 5, but this works. Okay, sure.
Okay, yeah.
Okay, that's fine. So let's go ahead and. Oh wait, hold on. Okay. Let me go ahead and. So I'm going to give you a doc for now, but what do you feel like you're messing up the most with? What do you really struggle with?
The most I struggle with is just like being consistent with like my problem solving. Like I mentioned, certain patterns, or like stuff that I practice a lot. For example, like trees and graphs. I practice more on trees and graphs. So like seeing those questions, I'm able to kind of visualize and like have that breakthrough moment a lot easier compared to problems like DP. I barely practice on DP mainly because I was aiming for Facebook. But right now I'm trying to ramp up on it. But that's kind of like the main issue I'm having. It's just like consistency. Sometimes I feel like I feel super confident because I'm able to like tackle some problems and solve it like pretty quickly. But then sometimes like I get like the opposite result. Mm-hmm. So yeah.
Okay, because I'm trying to figure out like what problem to give you, and I think that I want to give something that is perfectly within your comfort zone. So I'm gonna give you a tree problem then, since you say like
Okay.
it's easier for you to actually, get to the solution. So let's go ahead and
Yeah.
get started.
Okay.
Timer. All right. Let's see. And here we go. Let's
Okay.
10, 18. Cool. So, given a binary tree, I want you to find the lowest common ancestor of two given nodes in the tree.
Okay.
I don't care if you've seen this
Yeah.
one before or not. We're just here to analyze your thinking and approach.
Okay. So when you say two given nodes in a tree, are these two nodes guaranteed to be in the tree?
Mm-hmm. Yep.
Okay. And then they would be different nodes, right?
They may or may not be.
May or may not be. Okay.
But
And what about the
let's assume
value?
let's
Sorry.
assume for now that they are. But I let's assume that they're different. But ideally, your coach should be good enough to handle the case when they aren't. So.
Okay, I'll just kind of note it down like that.
Mm-hmm. Sure.
And as for the values in the tree, are they going to be unique?
Are the values in the tree going to be unique? Well, you're going to be given node objects, so you can
Okay.
assume that the node objects it's not going to be a graph where you're going to have a lower child attaching to an upper child. So.
Okay, I'll just be comparing like the actual addresses, like the node objects instead of just the values then. In that case. And when we say lowest common ancestor, I assume like this would include like a node can be its own lowest common ancestor, right? For example, if given this example that you have, and say the input was 5 and 1, then obviously it would be the root at 3.
Yep.
But say if I was given 3 and 5, then it would be at 3, right?
Yep.
Okay. And okay, so let me think. So obviously, like with trees, there are like two types of traversals, BFS and DFS. But with this, I'm thinking about definitely doing a depth first search approach. And okay, looking at tree, okay. So at every node, we would basically have to check if the node itself is one of the two given ones. And I would also need to check if the left subtree contains one of them, as well as the right subtree. Okay, and let's see. Those are the three main cases. Okay, and we know that it's let's not even care about like the lowest common ancestor, but a node is going to be a common ancestor if 2 out of 3 of the conditions are fulfilled.
Okay.
Does that
Wait.
make sense?
Okay. If the node itself is one of okay. And right left tree, right tree. Okay. I see what you're saying. Sure.
Okay. Okay. So that makes sense. What I'm thinking is like I would kind of call a helper function to kind of do the DFS on the tree.
Mm-hmm.
And the helper function will essentially check 3 things. So it will be like checking if the node is one of the two given ones, and if the left subtree contains one and the right subtree contains another one. And here, since we're being told that the node objects are unique, since we'll be comparing address or like comparing the node objects themselves, we don't have to worry too much about the left subtree or the right subtree containing two, and then the other one will still return true. So it should be safe to assume that if this one returns true and this one returns true, then this should be false and stuff like that. Does that make sense?
Say that again, but more simply.
Okay. Because we are guaranteed that all the node objects are unique, we don't have to worry about getting ambiguous results when doing these checks.
Okay. Yeah.
Okay. So let me remove these just to avoid confusion later. Okay. So Like I mentioned earlier, I'm just gonna begin writing some pseudocode. But essentially we have a solution class, and I'm gonna like kind of start with the helper function first because that's gonna like be like the gist of the algorithm. So it's gonna basically check, if the node is null or not, and if it's no, we just return early. After that, we're gonna first check the first thing is say if node equals to say input one. So we have, let's define the input just to be clear. So input will have root, which is the root of the tree, and then we have node 1 and node 2 as the two different nodes that we're supposed to find the lowest and common ancestor for. So the first check is checking if node 1 equals to the current node equals to node 1 or node 2, and then that's going to be the first case. Second case, we're going to be checking the left subtree, and by doing that, we can basically just call the left subtree helper function, not left subtree, and then there would be helper function on the left right tree. Now, because I'm doing this, I'm going to be coding in Python. I could do, and true or false kind of, you could use them as integer values, so I could kind of do something like first condition plus second condition plus third condition equals greater or equals than 2. That's basically gonna guarantee check this condition I mentioned above if 2 out of 3 of those conditions are fulfilled. And if that is fulfilled, I can basically do the update global. Now I just want to make sure that we are going to get the lowest common one out of all of them. So I'm gonna go back up with the different input we have. So if we have 5 and 1, then the only time it would return true is when we're processing the root node. So that works. If we're getting given 3 and 5, the only time it would be true would also be at the root node. But let's try something that's a little further down. 2 and 4. So 2 and 4. 7 and 4 at the very most bottom. At node 2, this will update the global. And then when we at, okay, that works. But when we at other nodes, for example, 5, 6, 3, those would not work because only 1 out of the 3 conditions would be fulfilled. Does that make sense?
Yeah, that makes sense.
For example, at node 5, okay. Yeah, that's basically I think pretty much the gist of the algorithm that I'm gonna code out. If that makes sense to you, like go ahead and code it out.
Go ahead, do what you need to.
Okay, sure. Mission, we're halfway done. Let's just call this find LCA. So we're given root, node 1, node 2, and we're going to return, let's see, okay, we're going to return that. Is it safe to assume that the node class is defined and I could just kind of use...
You could assume no class has your left and rights in them.
Okay, sure. So just to, like mentioned before, I'm going to have a global variable. So I'm going to define a LCA equals to none for now. And I'm going to call the helper DFS function on the root node and pass in the node 1 and node 2 to be used for comparisons. And in the end, I'll just return LCA, which would be the result. Okay, so onto the helper function, I have the current node, node 1, and node 2. So if, like mentioned before, if not node, we just return. So this would handle the case where we get an empty root because we already defined LCA, the result, like the result as none. This is just going to return immediately, and we will not return any invalid node or anything like that.
Sure.
So moving on, we have to do the 3 conditions. So one would be self. Let's not do self. Own. Okay. Own is equals to node equals to node 1 on node equals to node 2. and then left would be helper DFS. Helper DFS. Okay. Yeah. Node dot left 2. Now I'm gonna tick back on that. I'm just gonna return false here, so I could also handle the case where the child node is empty. Even though this return is not gonna be used in the highest level. And I'm gonna do the same thing for the right subtree. And moving forward, like I mentioned before, if on plus left, actually this is equals to 2, then we do non-local to kind of get access to the variable, and we'll do LCA equals to current node. And in the end, we would have to return, let's see, on left. All right.
Okay.
Okay. Let me run this through like an example just to be sure. So taking the example you gave me, if we're given 3 and 5, then we'll basically start at the root node, and this would be true. Left side would be true as well, because when we run it on the left side, it's gonna immediately check at node 5, left and right are both gonna be false, and so we're not gonna update the LCA, but it's gonna return either one of these conditions, and because itself is one of the nodes, it's gonna return true. So left subtree is gonna return true when we're processing the root node, and because the root node itself is one of the nodes, this is going to be 2, and we're going to get the LCA, and we're just going to do the update and then return. Using the other example that we had earlier, 7 and 4, if we go all the way back, all the way down, when we're processing either node 7 or node 4, only one of the conditions is going to be fulfilled, so it's not going to do any updates to the LCA. But when we go back up to node 2, it's going to update the LCA. And subsequently, when it goes back up further up, like 5, 3, we're not going to update the LCA because it's only one of the conditions is fulfilled.
Sure.
Yeah.
Okay. Okay? I see what you're doing. Is there one other optimization that you can make here?
So based on the examples that I'm seeing right now, it seems like we only do the update once, and it seems like once we do the update, we could just kind of stop traversing. I'm just trying to think like if I miss anything in terms of like if we would need to do the update more than once. So I'm just gonna, if you don't mind, I'm just gonna like kind of list out a few more examples and see if we will only do the update once. So if I do N6, only once. 0, 1 to 12. Yeah. Okay. Yeah, it seems like I would only need to do it once. Now I'm just trying to think like how would I break the entire thing once I get the LCA. But that's the only part I could think of right now in terms of optimizing it, because it seems like we definitely wouldn't need to continue running this on other nodes once we're finding the first LCA, or basically the first node where this is fulfilled.
I mean, yeah, that's pretty much it. I was just asking if you wanted to write that down.
Okay. To write it out, sure.
Yeah, and just like put it in your code, like.
Oh, okay. Yeah. That's what I'm trying to think. Like, how would I put that with the current way I coded it out? Because I'm returning booleans. So. This may be a little hacky, but I could do something. This could be anything, but it just serves as like an identifier.
Mm.
To tell me that I've found the first LCA, and at all the points where I do the check, for example, here, if any of these is this particular value, I could just no, that wouldn't work as well because I would need to kind of throw it back all the way back up. Let's see. Okay, yeah, okay, I think I know what to do now. So instead of doing it here, I could define it all the way up here. And so that I have access to the, sorry, after the node check, okay. So I'll do it over here, so I have access to the global variable earlier.
Sure.
And the moment, if this is not none, we can just return instead of doing all the additional computations. Because once this update is done, every subsequent runs is gonna have access to the actual LCA, and we could just return instead of doing any processing. Does that make sense?
Yeah, that makes sense.
Okay.
But I would also say, okay, not none. Yeah, that's fine. That's fine. All right. I'm gonna say that you aren't you gonna? Doesn't it need to return 0 or something instead of a none or? I guess you've defined to return false here, so shouldn't this return a boolean too?
Okay. Yeah, that makes sense.
Yeah. Okay.
And just to be consistent, I also remove the it's not none, just because I've been using not and if directly instead of comparing to none.
Whatever. Yeah. Okay. Time space complexity of this.
Okay. So time complexity, worst case, we're definitely gonna do O of n because we will need to traverse each node at least once in the worst case.
Mm-hmm.
And for space complexity as well, this is gonna be O of n because we'll be traversing through the entire tree. And in the worst case, if it's say linked list, then we would just kind of keep going, and the recursion stack will kind of just add up to be the entire tree.
Okay, how are you sure about that?
Yeah. So, because if we have a linked list, then say like it's all on the left side, this would just keep going left.
Okay, sure. Let's say it's going left, right?
Okay. Yeah.
What's the height? How long is that list?
That list would be like the amount of nodes in the tree.
Really? 3, 5, 6. How many nodes is that?
No, I'm saying if this was more like a linked list, like the tree is skewed. Then instead of 3, 5, 6, it wouldn't be 3, 5, 6, right? It would be something more like 3, 1, 0, 8, 5, 6. It would be all the nodes, but in
But that's worst case.
Yeah.
What's average case?
Oh, average. Yeah. Okay. Average case, we're gonna have a log of n, or basically the height of the tree.
Mm-hmm.
Because that's pretty much the amount of nodes we have in typical binary tree scenario.
Okay.
But yeah, worst case, if it's skewed tree like a linked list, then we would have O of n.
Okay, I'm fine with that. All right.
Yeah.
Let's stop here. I'll stop the timer here. All right.
Okay.
I want to know, like, did you see this problem before? You seem pretty comfortable with this, so I'm kind of curious.
Yeah, I've seen this problem before. And it's pretty similar to like the other tree problems that I, have practiced on. For example, like diameter, width, maximum path sum, stuff like that. It's typically that's why I mentioned like with tree problems, because I do practice them. With DFS, I feel like sometimes it's just kind of figuring out like what to do at the current node, and then just making sure like if the cases are covered, then it will just kind of propagate itself and work. And that's what I mean like with patterns that I do practice with, I do feel comfortable. But when it comes to like arrays and strings or DP, like there's a lot of different variations, and like I seem to struggle to find like a way that works for me in terms of consistency. But for trees, like I like to kind of imagine like, oh, whatever would I do at this current node, and make sure that works at every node.
Sure.
But yeah.
Don't worry, I have plenty of things to talk about with you anyway. It's like you're not as perfect as you think, So
Okay.
let's hear.
Yeah.
So let's talk about the time stamps. So first things first, I did like the beginning. You clarify the parameters of it. You kind of figured out like what you need to know for the DFS, and you use DFS. Okay, fine. This means that you recognize the pattern, but the small red flag is that, well, where is this idea coming from? But I get it. You work with trees enough. It's gonna be a BFS or DFS solution. That's fine.
Okay.
But my concern is that actually when you first wrote the pseudocode for it, is like, did you run through your idea? Did you test it? How do you know it 100% works? That was the biggest issue, I think, here. And I'm going to tell you how it bites you later on. But the first thing is that when you wrote that pseudocode, and you said, oh yeah, let me do this helper function, you were already married to the idea of DFS, which is fine, but the thing is that you don't know how that actually plays out in terms of an algorithm. Because, the things that we think about in our head and how it actually behaves is always, there's going to be a disconnect, right? So what I would have liked for you to see, is that if you've written this before or after at some point, to actually just run through the algorithm, and just like walk through like how it might look like, maybe with a stack trace or something, like at least with like a baby example, just to make sure you get the gist of what you are measuring, what variables you have to maintain, and et cetera, et cetera. The way it like actually kind of bit you a little bit is that, well, for one, I get you're like testing 7.4, but that's like that's an isolated case. You're just like, oh, what happens if I just plug in 7 and 4 from this tree and I'm going in here? Well, the thing is that you don't actually know how your whole function is going to work. What other variables do you need to maintain? What's your return values, and how does the return values actually affect your function? And so, even though this like might seem literally nitpicky, it actually shows itself when you need to actually do the optimization. So, for instance, this LCA, right? You struggled with it. For me, it was a very simple, like, I just put this at the top. But you spent like a good 3-5 minutes just trying to figure that out. So this tells me that you're not even familiar with how your own algorithm runs. And that's probably the big red flag here, is that if you can't make a simple optimization like this, then you are writing down a code that you don't really actually understand. That's the biggest issue I see, is that because you see how these things are connected, you didn't actually run through the whole algorithm, and so you couldn't even make a change on it. So if I was asking a little bit more complex problem, and then I asked and you solved it, and then I asked you to like, oh, well, what happens if I want to accommodate for another case, and I ask you to optimize on top of it, you'd be kind of fucked. And I know Google loves doing this, actually, so this is why like you need to be able to run through and test your idea before you commit to it.
Okay. And I have one question. So you mentioned about like testing through like the like this is the pseudocode, right? And if I were to test through it, would it be like kind of like just having like a stack trace like you mentioned, and just kind of going through like the example we have here and just kind of talking through it like that?
Personally, I would say I would roughly describe my algorithm instead of like doing this. Like I get that you kind of want to do, like I get why you're doing this, but personally for me, I would at least do a run through of it, even if it's just in this form. I wouldn't be, it's like I'd be saying, okay, I'm gonna look at 3, and then I'm gonna look at I'm gonna see if this node is not null, and then if it's null, then I will go ahead and do it. Then I go to left child, or like do the evaluation. I'd actually say exactly what I was doing and at what node. So you've seen me do this before, like I'll be saying 3, check node equals null, false, okay, so then continue, and then I'd write LCA if that's applicable, but let's say I didn't do LCA. Let's say I did own node equals to 1 or 2, no, okay, and then keep going, and then I'd recurse into left, and then I'd write this, and then 5. You see how fast I was able I'm doing that? And it's really just a sanity check. I'd probably only go up to like the example up to 7 and 4 and just say, hey, yeah, we're good. And then I actually write it out. And this doesn't take that much time at all. It takes like 3-5 minutes just to run through it. But that's the 3-5 minutes that you're saving with the LCA optimization. Instead of you fumbling around through it, you actually just walk through it, and not only will it protect you against like a mistake like this, it'll protect you from other mistakes, and you probably realize what you needed sooner rather than later. Okay. So that's my nitpick there, but I suspect that this might actually be the reason why you're not able to actually figure out a lot being consistent with your problems. So when it comes to like strings and other things, do you actually try walking through your pseudocode before you actually code?
I do, but like with strings and arrays, I also kind of struggle with like coming up with like good edge cases.
Okay.
Um, yeah, because with like trees, I feel like it's easier for me to kind of like think about like what are the edge cases, but with strings and arrays, like some problems could be um kind of hard for me to grasp and like kind of think about like the really like edgy cases.
Mm-hmm.
So like when I run through my pseudocode against like the cases that I could think up of, they seem fine, and then when I actually run it or submit it, like it doesn't work, and then I'm like, oh, I missed that edge case kind of thing.
I see. Okay, so I would say it boils down to your ability to recognize what test is meaningful and what is not. And I kind of touched on this a little bit. But to me, like you were kind of testing things randomly, like 7 and 4. It's like it provides no difference than 5 and 1. And even you admitted during when you're testing it, it's like, oh, I need to test something deeper in the tree. Well, then why not just walk through it? And another way to test these things is to test all the combinations of like these statements. So for instance, let's say I'm walking through this code. I need to test whether or not this node is null. So which means one of my test cases is going to be if node null or not, right? Another one of my test cases is going to be walking through the pattern and then making sure that if LCA is triggered that it later on and I recurse back in that I don't do this again. That's gonna be one test. Another test is going to be if the current node is node 1 or node 2. And sometimes it will be, sometimes it won't be. And that's what I mean. The beginning of the test just means like, hey, this code has the option of branching into XYZ factors. Let me come up with a test case that branches into these. So for instance, this like the helper DFS is going to return true or false. What happens? Can I come up with an example where the left returns true and the right returns false, and vice versa? Even though these like technically the same. Sorry, go ahead.
Okay. I do have a question. So yeah, like I think you mentioned like testing on combinations of statements is a good thing, but what if I don't even have like the code yet, and I'm like trying to think of like cases to kind of handle before I write the code, or like have like an idea or pseudocode. Because right now, like when I have the code, like I can just, it's easier for me to test because I can run it through like the combination of statements, like you mentioned. But if I'm at the beginning where I'm still kind of exploring and see like how would I handle this in code, like how would I like be able to kind of find like good test cases?
That's a good question. You're basically asking how do I test things if I don't even know what I'm testing, and that's the thing.
Yeah.
Like,
okay.
I was gonna say, like, literally, once you walk through it, you will understand immediately. Hey, this is where I kind of fucked up. Here's like where we can potentially have some pitfalls. And then once you actually walk through the algorithm and you look at it, then you can understand. Oh yeah, I need a test for this, this, this. But if you can handle like 90% of it already, then the last 10% should come very easily. I think that's usually the good rule of thumb. It's not like you have 1 or 2 test cases that blow up your entire code. That's very rarely the case. Like, unless you miss something so incredibly obvious, then it's going to be like, oh, yeah, shit, But most likely, more often than not, as long as you, like, walk through an example and just try to imagine, like, what can go wrong at every single step, you're going to be fine. So. Okay. So, I'm going to give you a string problem, and I really want you to make sure that you run through the idea and you test it before you do it, and see if that makes a difference.
Okay, sure.
Okay. And I will time on this since the last one was just too easy for you.
Okay.
Oh, this will be fun. Okay, let's restart the timer. Oh, that's not it. Where the fuck did it go? The fuck? Oh, there it is. Alright, let's go. So, suppose I gave you a block of text and a set of strings. I want you to find me the shortest string in the block of text that contains this set of strings. So let's run through a few examples. Suppose I gave you a set. I'm looking for like a set, looking for the characters, the words 2 and 4, right? Well then, in the block, and suppose the block of text I gave you is 1, 2, 3, 4, 5. You would return to me 2, 3, 4, because it is the shortest string in this block of text that contains 2 and 4, right? And you want to make sure that this every single word is congruent, right? So it needs to include 3. And if I give you another example, like even if it's like 2, 1, 2, 3, 4, 5, you would still return back 2, 3, 4 because if I took 2 out here, then it would be it would be too long. And there's a shorter block of text here, right?
Yep. Okay.
And the reason why we're asking questions like this is because it might be very useful for cases like Google Books, where I am looking for a bunch of keywords, but I don't know where these keywords might be, so I need you to return a what's called the block of text that's going to contain all these keywords that I remember. So.
Okay. That makes sense. So looking at this, I do have a few questions. So is the input always, could it be like any type of characters? Like for example, it could have to be like digits or like special characters, any sort of like that.
You can exclude the weird Unicode stuff. Let's just focus on English words for now.
Okay, English words for now. And obviously I'm seeing, we could have duplicates as well. Duplicates allowed. And for, let's call this like, it could be the haystack or whatever, but it's not, is it guaranteed that this, the length of this is shorter than what's given?
You should be your code should be able to handle the case where, like, let's say like I gave you like 2, 3, 4, 1, 5, whatever. Your code should be elegant enough to be able to handle that.
Okay, for sure. Handle with one needle. Okay. When you say set, this is basically just a string of like, and one last question is that, are they gonna be delimited or like separated by space, or it could be anything?
They're gonna be separated by space. Like I said in the beginning, we're gonna pretend this like a book.
Okay. In that case, since I'm giving like this is a set, right?
Uh-huh.
Oh, is this a?
It's
okay,
gonna be.
So
It'll be a set.
Okay, so I won't have say 2, 2, 4, right? And that would force me to have 2 2s in the needle, right? It's just gonna be one of each.
Yeah, it's gonna be one of each.
Okay,
I mean, even then, it should not matter. But yeah, sure.
Okay. Okay. So looking at this, the first thing I'm thinking about doing is definitely like kind of splitting this by space so that it's easier to kind of parse through it. So I would kind of translate the string into a list. And once we have that, it would kind of just be iterating through the string. And since the substring or the shorter substring needs to contain all of these keywords, then it's kind of obvious to me that we would kind of need like a sliding window approach in order to cover all the keywords that we have. And we could always ignore the ones that are not relevant, but they have to be included if we want to include like all the keywords in the sliding window. Initially, I was thinking of having a set just to keep track of what we have here, but like you mentioned with this example, we could potentially have like multiple keywords in the same multiple same keyword in the substring. So I'm thinking about using a hash map instead, so we could kind of keep track of the frequency.
Okay.
And yeah, so I would have a hash map to kind of store like what we have, and I would also substring, and then we have. Okay. I'm just gonna name the input right now so that we could kind of start talking about like how we would handle this. So I'll give an S, which is the input string, and I'm given keywords, which would be a set, and and hash map, frequency. So I'm just gonna have like a for loop, and it kind of acts as the end part of the window. And in the beginning, we would have the start of the window at 0. And at each iteration, we just add the current word into the hash map. And obviously, like if the word already exists in the hash map, we just add the frequency if it already exists. And okay, so once we okay, so and we know that we have all the we can know that we have all the necessary keywords the moment the length of the hash map is equal to the set of the keywords. This is because we know that each keyword is going to be unique in the set, and the hash map is going to basically have a set of unique keys in it. So the moment these length are equal, then we could basically know that we have all the necessary keywords, and at that point we can start kind of decreasing or like minimizing it to the point where we can no longer minimize it because we're trying to find the shorter string as the just like a question. So for example, in the second example, we start with 2. I could use a hash map. So we start with 2, and initially we only have one of it, and when we get to 1, because it's not in the one. Okay. One. Okay. Yeah, I'm gonna ignore 1, like I mentioned, but I'll be able to kind of keep track of like the length.
Okay.
Just by the 2 pointers. So
Okay.
moving on, I move to the second 2. Then I
Okay.
can increase the frequency, and then I go to 3. 3 is not in the set. Sorry. So yeah, 1 is not in the keyword set. I ignore it. I go to 2. It's in the keyword set. I increase the frequency. I go to 3. It's not in it. I ignore it. I go to 4. I add it into the hash map, and now I know that I have all the necessary keywords because the length of the hash map is the same as the set. And from that point on, I could start kind of decreasing the window from the left side to the point where it no longer is valid. So right now, this is valid. This is a valid state. So I remove the first 2, and I kind of increase the start pointer, and I get to 1. It's not in the keywords. I just kind of ignore it. I move on to the next 2.
Okay.
And when I remove, sorry.
Okay, so you're gonna decrease the frequency by what?
1.
Okay, but how do you know where the next 2 is? Are you just gonna be iterating, or what?
Yeah.
Okay.
So I have a start and end pointer.
Okay.
So yeah, n is the for loop iterator. And start is a pointer that begins at 0.
Sure.
And it's only increased when we have a valid window. And by a valid window, I mean a window that has all the necessary keywords.
Okay.
Yeah, and we'll continue increasing it until window is no longer valid. And at every iteration, we will also kind of keep track of the minimum valid substring. I'm just going to name this something for now, but we can rename it later. But minimum valid substring as the answer, and we could just kind of check every time we have a valid window, and we do this iteration. We could just kind of do minimum, and that valid substring, and we have like an start. Yeah. So going back to the example, like I mentioned, I don't need to know like when is the next 2. I just know that I still have 1, 2 in the current window because I'm here, and at this point I'm still valid. But the moment I process the 2 with the start pointer, I'm going to remove it from the hash map.
Okay.
And this immediately becomes invalid.
Sure.
And I'm going to stop increasing the start pointer at this point. And so now the window is just going to be 3, 4.
Okay.
If that makes sense. And start is going to be at 0, 1, 2, 3. Okay, yeah, this is going to be over here. And it's just going to continue moving on. So we basically just paused the moment we had a valid window. Like we added 4 into the hash map, and we had a valid window. So we just started kind of increasing the start from the left side and removing stuff from the hash map until we get an invalid window, which is at 3 and 4. And now we'll move on to the next iteration, which would add 5 into. Sorry, we wouldn't add 5 because it's not in the keyword. But yeah, and then we would reach the end, and we would have the minimum valid substring answer because we would kind of check it and get the current size based on the add end and start pointers. Does that make sense?
Yeah, that makes sense. You're basically doing a sliding window, and I understand that. I think it's okay. So what do you want to do now?
if things make sense to you, I could writing pseudocode. Start writing pseudocode. If that makes sense.
It's up to you. However you want to run this. It's up to you.
Okay. I could just write some pseudo, like pretty close to code, just to kind of get started.
Sure.
That's okay.
However you want to do this.
Okay. So, solution, and this is going to be and we'll have a keywords, which is going to be set. And okay, so looking at this, we would start. So yeah, like I mentioned, I'll have a start pointer that's going to be 0, and I'll have a hash map that's going to be dictionary. And the endpoint is just going to be the for loop iterator. Okay. And yeah, let's just paste this over here so we can kind of walk through it real quick. This is like, I'm just going to write. So if, so what kind of word is going to be? So I'm going to delimit it and split it into a list, like I mentioned. And I'm just going to run through the string and process it. If the word is in keywords, then I'm just going to add it to hash map.
Okay.
Else I just do a continue, so I would just ignore it. And actually, I could, in order to make it cleaner, I'll do it the other way. If the word is not in keyword, we just simply, go to the next iteration. We don't even care about this. If we get here, then we know that word is for sure in the keywords, and then we would just kind of add it to hash map and basically increase its frequency, if any. Mm-hmm. And then now we would check, if the window is valid, and by doing that, in order to do that, we would basically do, if the length of the hash map is equal to the length of the keywords, and this is how we know we have a valid window. And the moment we have one, we're just gonna increase the stop pointer.
Okay, that's fair.
And remove the left character from it. As long as we are valid, we're just gonna keep doing this. And every time we do this, we're also gonna keep track of the minimum result, or like minimum length as a result. Does that make sense?
Yeah, this makes sense. I will say,
okay.
Let me know when you're done, because there's a few things I want to say.
Okay. No, you can go ahead.
Okay, so I'm going to say that it seems like it works, but
okay.
Let's first start with the time space complexity. What's the time space complexity of this right now?
Okay. So the time would be if we. Strictly speaking, it would be 2 of n, because then at most we would have to process each string twice if we do the increase and the expansion and the compression, like we do it twice, so 2 on n, but asymptotically it would just be O of n. As for the space, we're going to be storing at most pretty much the amount of unique words we have in the given string. If that makes sense.
Okay.
If these are all unique, then we would have. Okay, so let's just say n is equal to number of unique substrings in the input string, and so space would be O of n.
Okay. Like you said, okay. You're iterating through the window. You're iterating through it twice, correct?
Yeah. Yeah.
And so is there a way to do this, iterating only once through the string?
Iterating through once. So meaning we only process the string each. You're saying that we process each substring once.
I'm saying that your sliding window effectively means you have one pointer that is iterating through the block of text, and then you have another pointer iterating through a block of text, right? And in the case of like at scale, let's assume that we're at scale, right?
Yeah.
That our body of text could be like millions, billion words, right? And we're only really looking for, let's say like 3 or 5 words, right? So this solution is going to be kind of long. So my question to you is, can we make it so that way we only have to iterate one time through this body of text?
Okay. Let's see. Yeah, I'm actually thinking like we might be able to if we keep track of the indices, like the indexes of the keywords that appear in the block of text. If that makes sense.
Sorry, repeat that.
It would work if we keep track of the indexes of the keywords in the block of string.
Sure.
That's what I'm thinking.
Okay.
Because like for example, like if we have like a large book and we only want to find for two words, then but even at the worst case, we would still have to go through the entire book and go through each word once. So we would still need to go through each word, and we would have access to the index as well, so we could basically kind of keep track of like the indexes of each keyword. But I'm trying to think of like how I would kind of utilize that data in order to compute the shortest string in the block. But instead of just thinking blank, I'm just kind of list it out of what I have. I'm just going to use the second example just because I like how it has the double twos.
Sure.
So in this case, we would have, we would kind of do a pre-processing through the entire block of string, and we would have a 0 and 2 because those are the indexes, and then 4 would be, yeah, it's going to be a 4. And it doesn't matter, like, in what sequence these appear, right?
It doesn't matter, yeah.
Okay. Okay. This, looking at this example, it's easy. We could just kind of take like this example is easy, but I'm trying to think like what would be the way to kind of handle this so that we could always capture like the correct result. So I'm just gonna like kind of list out the other ones as well, just to make it easier for myself to see a common pattern between them.
Okay, so yeah, you have the indexes now. What's your plan now?
I'm still having issues seeing a common pattern that I could utilize to compute the minimum substring that contains all the keywords. Like I know these indexes would be useful, just because I could kind of use that to find the minimum. But I'm like I'm struggling to find a way to do that. Like I was thinking about using like minimum maximum, but then that wouldn't really work if we have like a lot of different keywords, and we would end up doing a lot of cross-referencing.
Okay.
With other indexes.
Okay. Okay. One thing I do know is that the longest, so let's not even talk about the shortest string. Sure.
But the longest one is always going to be like the smallest value we see.
Okay.
To the biggest value we see. That's one thing I noticed. It's like, no matter like what we have, like the longest the longest answer is going to be 0 to 4, because that's the smallest value we see, and that's the biggest value we see.
Sure.
Now I'm trying to think like, well, what way we could do to shorten this if, say, we have like multiple indexes in each of these keywords.
Mm-hmm.
Mm-hmm. Like I'm thinking like I would like go with check on like the keyword that has the smallest value, and then kind of checking like the subsequent indexes in that keyword. But then that also wouldn't quite work well if we have like, say, another keyword here, but it has 1, and I'm trying to look at the next one, which would kind of defeat the purpose, because we would still need to take that into account.
Mm-hmm. Seems like you're a little bit stuck, though.
Yeah. Okay. Yeah, and I know I could ignore like the ones that only have 1 values, because then like they would need to be included no matter what. But like I said, like if we have like a lot of input and most of them have multiple indexes, I'm still struggling to find a way to kind of compute that.
Okay, let's do this as an exercise.
Okay.
What is your objective right now? You need to do what?
I have to find the shortest string in the block.
Okay, what's preventing you from doing that?
A common way to basically a way to determine that shortest string based on the values I'm given.
Okay. What is the most naive way you can think of to find the common string? Super naive.
I would basically take like the
what's the most naive way you can think of? Like, let's suppose we didn't have this index for now. What's the most naive way you can think of in a body of text to get you the answer that you're looking for?
You mean like without this approach we're talking about?
Pretend it doesn't. Just follow me on this for a little bit. Okay. Pretend it doesn't exist. Sure. Pretend it doesn't exist. What is the most naive way you can think of to getting the answer?
We check all the substrings, all possible substrings in the string, and find the shortest one that contains all the keywords.
Right, but that's obviously very inefficient because we're trying every single possible substring. Now, can we do a more optimized version of that using this?
We would not need to. So we can still consider like all possible substrings, but we only need to consider all the possible substrings within the range of the minimum and maximum indexes we've seen.
Okay, but even better. Is there so that's within the range, right? Okay. But then, is there a way we can use these to generate those possible strings?
Yeah, we could use the basically the minimum and maximum in each of these indexes. Kind of like a small like substring of the bigger substring, if that makes sense.
No, it does not.
Oh, it does not. Okay. So say I have 2 here and it's 0 to 2. I would have this substring.
It's not 0 to 2. It's just what this represents, and you said, is the indexes in which 2 exists.
Yep.
So, and what we want to do right now, and this is the hint I'm giving you, is there a way to replicate that naive idea of trying every single string? Just that is relevant, using what we have here.
Oh, okay. We could compute the possible lengths
Okay.
based on the indexes given.
Okay.
So we would have 0, 2, 4, 5. We can have, so one would be like 0 to 5, and then we could have 2 to 5. That's what I'm seeing.
Okay.
Because I'm only taking the smallest and the biggest.
Okay.
And so this will give us 3. But I'm also not sure like how this will work when we have like a lot of.
Okay, let's give it a shot.
Okay, so
Yeah.
I'm just gonna put in say if that doesn't work. I'm trying to think like what would kind of interfere or like break what I currently have. No, this I'll pick 1. Okay.
Sure.
So in this case, it's gonna be 0 to 6. That's definitely the largest
Okay.
that we know. But I can't just simply take 2 to 6 because that wouldn't include the 1 over here. But if I were to compute all possible combinations,
I'm gonna give you 5. I'm gonna give you like 5, 6 more minutes with this. I get the feeling
Okay.
you're gonna be very stuck on this for a while. But go ahead.
Okay. So like, I'm sure like I could like if I'm able to get all the possible combinations, I could basically just pick the shortest combination in order to find the answer. But what I'm struggling is like finding a way to like compute all the valid combinations. I guess that's kind of where I'm stuck at.
Okay. So let's.
Because sorry.
So you're trying to compute all the valid combinations, right?
Yeah.
So, what is the issue that you're facing? Let's start there. Like, why are you having trouble?
Because when a keyword has multiple indexes, and I pick one, like say I pick 0 from here, I'm not actually sure like how exactly I would pick the another value from another keyword and say it's valid. Like for example, like I could just pick like anything. Like if I just pick any random or like compute all possible combination, I get 2, 4, 5, and I get 1. Or say I get 6.
Okay, so you're saying that you're gonna try every single possible combination of indexes, every permutation of at least one index from each one of these groups, right?
Yeah.
Okay, that's fine. I think that will work. But what is the issue here? Let me ask you that.
I'm doing a lot of duplicate computations, and I feel like there's something within these indexes that I could utilize to kind of remove that inefficiency.
Okay, that's fine.
And that's kind of what like I'm really stuck on. Like I know there's something I could utilize within these indexes that I'm failing to see.
Okay. Let me see. Let me write something down. Okay, so like you said, you're doing a lot of weird work. You're doing a lot of weird permutation combinations of a bunch of different things, right? And
Yeah.
is there a way that you can do this in a more efficient manner? So, what exactly? Let's clarify something. What exactly is the inefficiency?
I'm like looking at values that I may not need to even consider. Like if
Okay.
that's one thing. For example, like 4 and 5, no matter what, I don't really need to look at them. Like for this example, like I only need to look at these two keywords.
Okay.
That's one thing.
Okay.
Yeah, and I guess that's kind of where I'm stuck. Like, I know that, but then like I'm not able to kind of recognize what else can be optimized from that.
Okay. I mean, it's hard for me to tell you without telling you the answer,
Yeah.
really. But okay.
Yeah.
Oh, fine. I'll give you the hint, and we can discuss this later. But essentially, you're looking at 0, 1, 4, 5, right?
Yeah.
You're essentially looking at this, right? And let's say you did your computation with this. You did the length, right? What's the next combination you'd like to try?
Based on this, it would be 0, 4, 5, 6.
Why?
Actually, no, sorry. I would actually start with each keyword. So if I'm at this keyword, I'm actually gonna do 2, 4, 5.
Okay.
2, 1, 2, 4, 5, 1. Technically.
Okay, so then that'll be 1 to 5, right?
Yep.
Okay. Then what's the next element what's the next one you want to try?
It's gonna be 4.
Okay.
Actually, okay, but if, like I mentioned, if it only has one, no, I still have to consider it because it might be the biggest value. So I would go, 4.
What are you stuck on? What are you stuck on?
Like I could say like what I think about like what's the next combination, but I'm not sure how this would actually look in code. But say I go with 4, 0, 5, 1.
Wait, you're on 2, 1, 4, 5. I don't know what is this idea? Where is this idea coming from?
Because I was thinking like I was initially processing 2, and now I'm at 4.
Okay.
Okay, no, it's gonna be 4, 5, 1, and then 4, 5, 6.
Well, 4, 5. Okay, 1, 2, 4, 5. Right. Then what?
Yeah.
What? So you're at 4. What happens at 4? What are you gonna do?
I'm gonna do 4, 5, and 1. I think.
Are you going to advance? You last time you said 0, 2. You measured and then you advanced the pointer to 2, right? What happens here?
Yeah.
Are you just gonna skip? Or what's the next step?
Oh,
What's
no,
the next
no.
step?
So. Oh, okay. Sorry, I wasn't. I didn't get what you mean. I thought you meant like what do
You're
I
at
do
this
when
step now. Think step by step.
Okay,
What
okay.
are you doing
Okay.
at this point? What do you want to do in this point of the algorithm?
I'm finding the minimum and the maximum and basically take that value. So here, the minimum would, or like the difference, would be 4. Because it's 5 minus 1.
Right.
Yep.
Okay. What's next in your algorithm?
Okay, so 2, 1, 4, 5 is done. 4 and 5 are already in there, so I wouldn't add anything to it because it's already in there. I'll go to 1 and it's already in there, so I skip that, and then I would do 6. And because 6 is greater than the last.
Okay, write it out, because I think I know what the issue is. Your issue is you're doing this in your head. What does this look like now? Where's this 6 coming from, and what are you doing to replace it?
So currently I have 2, 1, 4, 5.
Okay. Where does 6 come from?
And 6 comes from the last keyword.
Okay.
Okay, but this I would have 4, and then moving forward, 1, 2, 4, 5, 1, 6. Yeah, I guess I'm still stuck in terms of like how exactly I'm approaching this. I don't really have a clear way of tackling this right now.
Okay, because let me
Yeah.
put it this way: you just advanced the pointer 0 to 2, right?
Yeah.
Why can't you do the same thing for 1 to 6?
I can. There's nothing stopping me, but I just wasn't sure like how I would like kind of do this in the code. That's why I'm kind of like afraid to say it as well.
Oh my. Okay, I know what the issue is now. Okay. Let me take a pause here because you're actually getting me kind of mad right now. Why are you thinking about the code?
Because I don't know. It's just like because I would eventually need to code it out, so I'm just like kind of thinking about that as well.
Yeah, but
But
you need to get the idea down. Get the idea down before you write the code. This is the whole thesis. We want to make sure our idea is solid before we type a single line of code. And what you're doing is because you don't understand like what the code looks like, you are letting that block you from developing your idea, which means that, hey, well, now I don't have an idea. Now I can't write the code. You are putting the cart before the horse, and that is what is screwing you over. When the idea is actually very simple and you already did it. All you had to do was follow through with that idea.
Okay.
You had the answer, and you're throwing it. I don't know how to describe this. You know what the answer is. All you had to do was just walk through it, because any idea can be expressed in code. But the problem is that you are doing it in your head, and you are trying to make the code evolve based on step-by-step ideas, when instead you want to consider the whole algorithm, and then write the code to express that. Does that make sense?
Yes.
So, let's go back to what you just did.
Okay.
So I'm gonna put on a pause here. So if you would just advance the pointer to 2, 6, then you could just try 2, 6, 4, 5, right?
Yep.
What's the length of this? 4. This is another candidate, right?
Yeah.
So you remember how I said before that this is essentially just us trying that naive idea of trying every single possible combination? All this really is just a substring between the minimum and the maximum. So it's just substring of 2, 6, right?
Yep.
And this is just substring of 1, 5.
Correct.
So literally, this is essentially what you're doing. You're essentially doing just some variation of 2-pointer, except it's 3-pointer. You know?
Mm.
It's like if I asked you to merge. It's the problem. Like if I asked you to merge 2 sorted lists. What if I asked you to merge 3 sorted lists, 4 sorted lists, 5 sorted lists? It's the exact same pattern, right?
Yeah, it is.
You knew the answer. You knew the answer. It's just that you didn't want to commit to it. So my question to you is like why were you so concerned with the code? Is this pretty? Do you think this is pretty easy to code up?
Now that I see it, I find it like it might be a little easier, but earlier I was like pretty lost, and so I was also worried about that, and that kind of affected like how I was.
It's almost like if you have a solid idea of what you're doing, the code's gonna be easy.
Okay.
Yeah, I'm being really harsh on this because I know this is the thing that's blocking you. But you see, like the moment I literally just wrote it out. The moment I literally just wrote out like what this actually looks like, it instantly clicked. This is just a substring of 0, 5.
Yeah.
And the moment I wrote that out for you, it just became so easy for you. And I have no doubt that you can code this up. I think you know that.
Yeah.
So, that's it.
Yeah, but I definitely kind of was like kind of lost in my head, worrying about the wrong things.
Don't do shit in your head. Never do that. Just
Okay.
write it out. So let's actually talk a little bit about like what you did here actually. So let me paste my notes.
Okay.
So, okay. So first 16 minutes, I thought it was fine. You knew what you were doing. You knew the pattern of the frequency map. You knew what you needed to do. Fine. Sliding window. You kind of had that intuition. But again, I think you have an over reliance on patterns. You have you instantly recognize the pattern. You're like, oh yeah, I'm gonna do this. Probably because you've seen it before. But this is where I said you need to really understand like what the naive solution is and why you can take these optimization steps. So in my guide, I wrote, yeah, you need to understand the pattern, but you need to understand under what circumstances it applies and how you can derive that from the naive solution. That's the second part I think you missed. You only did like, memorize the pattern. So understand what characteristics of the naive solution allow you to actually use this pattern. Because once you actually understood that, it's like, well, like, you know, you already described to me the Giga naive solution, which was, try every single possible substring combination of this block of text. Yeah. And then the sliding window was just like, yeah, well, we don't need to try every single possible string because substrings are substrings of another solution. So instead, we can actually just try string. We can just walk through the string and make sure that the window contains every single what's called string that we're looking for.
Yeah.
And had you just done that, I think you would have been able to easily identify that this frequency. I mean, yeah, I think me telling you, hey, yeah, what if we did the what's it called? What if we tried just using it with a frequency map? You would have come up with. I think you would, once you understood that, you would have come up with a solution. I think pretty quickly actually. And I think this is my note here.
Say that again. Sorry, I lost you for a bit.
So I was saying that if you had just done that exercise of like saying what it takes to go from the naive to optimal solution and why that works, and then I made you think about it in terms of a frequency map, you would have pretty much gotten it, I think. Like, but there were two factors that stopped you. So the first one is I had to walk you through the Giga naive solution, and then you said you're not sure how this would work if we did more. That was the one key phrase that you said, and to me, that just says, hey, I'm trying to do too much in my head. I don't know what's going on through your head. But notice here, like I even literally wrote, are you doing this in your head? And you are doing some shit in your head, you know?
Yeah.
So,
always.
Yeah. So it's like immediately I can tell like there's something going on here, and then all I asked you to do was like just walk through it, just try it out step by step. And then you were so resistant to it. It's like, oh, I'm not sure how this would work out. It's like, okay, just do it step by step. You remember how I said up in the beginning? Just walk through the problem. You could have just done that here. You could have just walk through your solution, see if it will work.
Okay.
You could have done the exact same thing. Just walk through it. Don't do shit in your head. And so like you just tried 0, 4, 5, 1. Well, all I need is a difference, right? And so and then you would have said, okay, well, what happens? What's the next thing I advance to? Okay, 2, 6, 4, 5. Well, then now I have to, or 2, 1, 4, 5, whatever. And then now the difference is 4. And then what's the next thing? Oh, I need to advance the 4 pointer. But technically, here's the thing. Like the key insight that you probably would have needed would have been like, just iterate through all of these until you reach the end on all of them. But had you just done that, and then it's like, oh yeah, 6 is gonna be, and then we're at the end of all of them, then you would have been able to say, hey, yeah, I've solved the problem, and then you could have thought of like some more optimizations and then written out the code. But just literally the only thing that was blocking you was the thought about code. It's like it just had to. All you do is just do what we talked about in the last problem and just walk it out. Just try walking through it. Just work out like what your solution might actually look like. So you can kind of see like even though the first problem you did it really well on and the second problem you did it poorly on, both of them just trace back to the exact same core issue. So, any questions so far?
No, I think I do get what you mean. It's just like I don't know, like at the moment, like when I'm doing it, it's just when you say walk it through, like do I just kind of like write out whatever I'm thinking at the moment and like whatever kind of like computation and like all kinds of operations that I'm kind of doing in my head?
Yeah, like basically put pen to paper. Like say, hey, my algorithm in general is going to be, I'm going to iterate through every single possible combination of these pointers, right? Or these indexes. But I recognize that there's a lot of inefficiencies here. So instead, what I'm going to do is just advance the pointers of these frequencies, right? And that's essentially at that point, before you started getting concerned with the code, that was the idea that's in your head, right?
Yeah.
Yeah, so that all you had to do was really just try it out. You kind of knew what the algorithm was going to be. You kind of knew what you needed to do. All you had to do left was just write that shit out.
Okay. I also actually kind of failed to see like I knew I had to like advance the pointer, but I also was thinking like I wasn't really seeing it as like a multiple pointer
Okay.
situation as well. Like I knew I had to advance it, but I was still thinking more of like a permutation kind of a way. Like
Okay.
trying more all possible solutions. I actually didn't really see much of like the pointer at that point, even though I was like saying the exact same things
Okay.
as like a pointer solution.
Okay. Let's say you still saw it as a permutation. Let's rewind it, right?
Yeah.
And then you said,
Right.
oh, okay, well, I'm going to try 2, right? And then
Yeah.
and then after that, you would have said, oh, well, maybe I need to advance the pointer back and then try 0, 6, right? Let's assume that you ran this train of thought.
Yeah.
And then I would say, why did you advance the pointer back? And you would tell me, oh, because we're trying permutations, right? It's like, do you need to try the 0 after you advance the pointer to 2? Let's assume that we had there, like, right? Let's
Okay.
assume this. And then you would have said, okay, if you tried it, you would have said, oh, I'm going from 0 to 6. You know, it's like, oh, well, the diff is too big. And then you probably start digging into why that is, and that'd probably steer you. And it's like, okay, well, let's assume that you were back at, like, 2, right? And then you just advance the pointer from 1 to 6.
Okay.
And then I would have made you do this, and then I would have said, okay, why don't you try doing it, draw it on a timeline or something like that. And I would have said 0, 2, 4, 0, 1, 2, 4, 5, 6, right? And then you would have essentially had 3 pointers. Or 4 pointers in this case.
Yeah.
And that would have made you draw it out. And then after that, you would have said, oh, yeah, because of that, like, 3 would, let's highlight it just to be
Okay.
a little
Yeah.
bit clearer. So then I would just be like, okay, then highlight it, and then boom, boom, let's keep this white, and then 4 would just be, you know, green, and then let's say that this is blue. Just
Okay.
and then suddenly, I think you would have immediately recognized, hey, wait a minute, this is just a me advancing pointers.
Yeah. Yeah. And it's pretty similar to like the merge list problem.
Yeah,
Like,
that's
put
really
out
all
this
this
way.
boiled down to, really. And the thing is that you instantly understood it the moment I drew it out. Why can't you draw it out yourself? Why can't you, like, just write out the problem?
Okay. I have to kind of work on that during my practice as well.
Yeah. Yeah, so, like, during your practice, I would really, really highly recommend, like, for any problem that you consider the naive solution, consider why your pattern works, and then consider shit like this, like, just, oh, the idea doesn't really work in my head, let me write it out. Very simply.
Okay.
Don't think about code. Think about this.
Okay.
Think about, like, what the idea actually looks like. Doesn't matter what the code is. Code you can write this in a billion different ways in code. It doesn't matter. Code does not matter. What matters is the idea. And I want you really to practice this idea of, hey, I need to test out my algorithm. I want to write out the ideas that are in my head. Does that make sense?
Yeah, makes sense. I think I definitely need to work on that. Like I even when I practice, like I think about a lot, but I don't always write down a lot of this stuff. I just kind of go through them in my head, and like I write down some stuff, but I tend to do a lot in my head.
Mm-hmm. And this is, like, I think that's what's contributing to your inconsistency, is that you do so much in your head that you just kind of forget, like, what your original idea is or whether or not it actually works. I'll tell you this. If it were me,
Okay.
I don't do computation in my head at all. I'll tell you this. My memory is completely garbage. Like, I would never try to do a problem like this in my head. I would literally just be trying to write down exactly my train of thoughts, even. I would literally be drawing arrows all over the fucking place and just say, hey, because I thought this, therefore I need to figure out this, and then I need to rewind my thinking, you know? I would never try doing a problem like this in my head at any point.
Okay.
Oh. Okay. Any other questions?
No, I think that was pretty clear
Okay.
on what I need to work on.
All right. Do you need like a 5-minute break or something? Because I know I yelled at you a little bit, but.
No, it's fine. No, I think I'm good. We could keep going.
Okay.
I think I'm okay.
All right.
Yeah.
I'm gonna give you another problem, and this time I really want you to focus on this idea of like, oh shit, am I stuck? And then actually fucking try the idea.
Mm.
Okay, I'm gonna try to avoid a tree problem here. I think I've given you. Have I given you red tape, blue tape?
No.
I like this problem actually. It's pretty good.
Okay.
So this is not like a string problem per se, but it's like Okay. So, given a red tape and a set of blue tapes, a tape is an interval x, y. First, stick the red tape on the table and stack it with blue tapes. I want you to determine if the red tape is visible.
Okay. Given a red tape and a set of blue tapes.
Yeah.
Okay, so only one red tape and a set of blue tapes.
Yep. So let me actually, you know what? I'll give you an example just to make it clear.
Okay. Okay.
Let me go ahead and pull it up. I love giving this problem, by the way. So here's an example. So for instance, let's say I have red from 3 to 6, and then blue from 1 to 4 and 5 to 8, right? There's a little section between 4 and 5 where it's visible. But suppose that I gave you one, what's it called? 3 to 6, 1, 5, 4, 8, right? Let's suppose in this second example, I swapped the 4 and the 5 here, right?
Okay.
And in this case, the answer is false because there's at no point is the red showing underneath. So.
I'm still trying to understand the example. So if it's 3, 6, actually wait, why would it not be example? First stick the red tape on the table and stack it with the blue tapes. Oh, okay. So this is gonna be on, basically on the table first, and then we stack like 1, 5, and 4, 8 on top of it. Is that correct?
Well, red. Yep, that's correct.
Okay. So even though there was no gap between 4 and 5, okay, I guess. But if this was 5, there would be no. It would not be visible. Is that correct?
If there's no gap, there's no. Yeah, this would just be this would not be visible. Correct.
Okay. So looking at this, like the naive solution would be kind of trying like let's see, as a start and okay, I think like say we have like a pretty large like blue input, like I think the naive solution would be get all the gaps between the blue intervals, if that makes sense, and basically see if red is like any of the gaps
Okay.
is within red's interval. And I could just do this by say like if I have like a list of gaps, for example, like I have like 1, 2, I have 2, 3. Oh, actually 2. Gaps would be like something like 5, 7. And in this case, I could just kind of run through the gap and see if it's within red's interval, and I can kind of do that by just checking if is in between red's start and red's end. That's kind of what I'm seeing. And when I'm also finding all the gaps between the blue intervals, I think it would just be easier if I have the blue list sorted as well.
Okay.
Yeah. So that's definitely one thing. I definitely want to sort the blue list because otherwise it's going to be pretty messy getting all the different gaps. And by sorted, I mean sorted based on the start interval, like the start key. Now, looking at this, this may not be very obvious now, but I also thought of like say we have like, pretty large list, and red might be pretty small. One inefficiency that I see with this is that we're computing a lot of unnecessary gaps. I kind of just want to compute the gaps that are closer to red, and I'm trying to like see like what are the conditions that define like closer to red, or like would be kind of valid to consider the gaps. So if I'm just gonna add a little more examples here, if that's okay, just to kind of. Okay, so if I have these sorted, I'll kind of have this blue list and okay. So I know I don't need to consider a, okay. I know I don't need to consider an interval if its n is before the start of red.
Okay.
Okay, so that I'm just gonna write that down, so I don't forget. Don't need to consider if n is before red's start. Let's see. Yeah, that makes sense, because whether it's there or not, it should not affect if red is visible or not, if that makes sense. And then I also don't need to consider if start is after red's end. So these are the two conditions I don't need to consider. Now going back to the main problem, say we already have a list of blue tapes that we definitely do want to consider. Like I said, I would just kind of compute all the gaps. And okay, I'm trying to see how, okay, once I have a gap, I just have to see there's any like, I wonder if it's intersection, if that's the right word, between red tape.
Okay.
Yeah.
So effectively,
That's
you're
kinda-
going to be trading one list of intervals for another.
Sorry, say that again?
You're effectively trading one list of elements for another.
Trading?
Like, you're giving up you're not looking at blue tapes, you're looking at a list of gaps between the blue tapes.
Yes. That's,
Okay.
Okay, that's currently what I'm thinking.
Okay.
Because that's kind of like what's intuitive to me right now.
Okay. Sure.
So say if I have 3, 6, I'm just gonna show you what I mean. And I compute the gaps. I would have blue would be, say 2 to 4, and then okay, 8 to 9. I know I mentioned like its start is before after red's end, but I'm just gonna put it here. Actually, let's just stick to what I have. So I have 2 to 4, right? That's the only gap that I care about, because these do not matter according to my conditions here. I just need to check if there's intersection between these two. And say if I have more here, I'm just trying to find a good example. Say if this was 10, then I would have the next gap would be 8 to 9, right? And the moment I find the first intersection, I can just stop, because that means I can return true, because it's like it doesn't matter if another part is visible. Like if one part is visible, we can assume like the answer is gonna be true.
Okay.
So yeah, based on what I'm seeing is that I would have, because I would sort the blue tapes list, and then compute the gaps. That means the gaps I have would be sorted automatically as well, and therefore I could just kind of go through element by element and see if there's any intersection between the current blue gap and the red tape. If that makes sense.
Okay, that's fine. Let's consider what's your time space complexity first of all.
Okay, so by time we definitely we use up log of n, and I'm just gonna define so m is gonna be the length or size red, and n is going to be blue. And we're sorting the blue list first, so we're doing that, and then we're doing computing the gaps. So that would take another like O of n, and in the end we will compare red to blue, and that's another O of n, because we're comparing each element for intersections. In the end, this will just be n log of n.
Sure.
And because m is always going to be basically an element of like a list of two numbers, so it doesn't really matter in this case because we're iterating through blue.
Okay.
And space-wise, this would be O of n, assuming that we use space. Like I'm assuming that we use up to O of n space during the sorting method, and hence the space here.
Okay, I see. All right, you're doing a lot of n operations as well, right? So,
yeah.
Is there a way that you can? Is there a way that you can reduce at least the number of n's here?
Yeah, actually, like I do see a thing that we could possibly just do one pass. I see that the computation of the gaps list might be a little unnecessary. If we have 2 pointers, so instead of computing an entire gaps list, if say I have 2 pointers, I can figure out the gap. That makes sense?
Yeah, that's fine. You can say have 2 pointers, you can
yeah.
figure out the gap, sure. But what exactly? How do you know? How do you know what these 2 pointer values are?
Because blue list is going to be sorted, then I'm just going to go with I and I plus 1 when iterating through blue tapes list, because they're sorted by start time.
Okay.
Yeah. The one edge case that I do want to bring up is in the case that we only have.
Well, I'm still not totally understanding this 2 pointer idea. What are you pointing to? And I and I plus 1. Okay. So you're iterating through the entire list of blue tapes, but.
Okay. I could show what I mean.
Sure.
So I have this list, right, and over here I would be right now. I would be this element, and I plus 1 would be 4, 8, and the gap would be the n of 2, or like, yeah, the difference between the n of the first one.
Okay.
Difference between the end of the first one and the start of the second one. That's basically what I mean by the gap. And with that, I could see if there's an overlap between the gap between the 2 pointers and red tape. And by doing this, I don't need to have a list of gaps. I could just kind of have like a variable to keep track of the current gap and see if that current gap has an intersection with the red tape.
Okay.
Does that make sense?
Yeah, but then question: what happens if I have something like 4, like an extra tape like this? Well, how do you want to handle it?
Okay, so and red tape would be something like, let's try something that would be valid without this, but not.
Sure. Yeah. Walk through your, like I said before. Walk through your idea. I want to see if it works.
Okay, so say I have this. So initially, this would be when we do the first 2, this would be valid, and then when we do 4, 10, this would be invalid because then. Yeah, so I'm trying to think like how we would handle that right now. So let's see. It seems like I would need to not just do I plus 1. I'm trying to see like how exactly I would handle this case. So if I'm taking gaps, I'm gonna go back to if then is before Ritz start. Okay, so this is start is after. Okay. Instead of doing that, okay, I'm trying to see what would be the condition I could use to move along with this. So I have 2.9. This, I have a intersection.
Sure.
And based on the previous algorithm, this would return true, but this would not be the correct answer if we move on to 410.
Well, it could be because
so
you have this gap between.
yeah.
It could be because you have this gap between 2 and 4. So.
Oh, sorry, my bad. Yeah. Yeah, that is true too. If I have 1, 4, 4, 8, there's no gap. Okay, yeah. So if there's no gap, I move on according to the algorithm. And I will move basically to 4, 8, and 4, 10. And 8 and 4, we're doing difference. And it has to be if the start of the second one, if start of I plus 1 is greater than the n of actually wait, sorry, not greater, less than n of I, then we also discontinue. We don't consider it because it's not invalid. There's not going to be a gap if the start is before the end of the first one. So we move on to the next one, 4, 10, 11, 12.
Yeah, what I don't like right now is that your algorithm's getting fantastically complicated. So I'm how about this? I want to save the last 15 minutes for us to put together a study schedule for you, but your homework is going to be doing this problem. I want you to do this problem, and I want you to get it to as optimal as possible, considering every single possible scenario. So homework.
Okay.
Finish this problem and make it simple.
Okay.
So to recap and practice what we talked about, walking through your idea. Don't think about code first. Think about the think about the test cases of your code after, and then or at least consider during your walkthrough of the idea, and then really just draw out your ideas. Draw out your ideas. Don't do shit in your head. Okay. So.
Okay.
In the meantime, I'm gonna get you a study schedule. Now I think you've seen my video on what a practice diary looks like, right?
Yeah, I've seen like 1 or 2 of them.
Yeah, I want you to be able to do that too. So, so let's do the R. I'm going to share this with you. Give me a second.
Okay.
Cool. Okay, so I'm just going to clone that. And we want to be able to target, let's say, the, I think we said, when did you want to target, actually?
So Facebook is a little more flexible, but I'm trying to do it before the end of the year.
Okay.
Hopefully, I just don't feel like staying as a contractor for that long.
That's fine.
So I'm just trying to get it out of the way. And then for Google, I know I initially said the recruiter was going to get me on site, and that's what she said as well. But she just came back and said she can't get me on site, but she can go ahead and schedule a phone interview. And I told her she usually said 2 weeks, but I said can I have it the second week of November, and she's okay with it. So I'm still waiting on her to get back to me on that. But yeah, it's gonna be the second week of November for Google phone screen.
Okay, so let's say 11/10 as a target date for that phone screen, and then the target on site will be 12/1. That way you can get your decisions by the end of the year.
Okay. Yeah.
Okay. So if that's the case, then let's do this. Hang on, let me go ahead and do something here. Good thing I did this with someone else, so I have the dates on hand. Yeah, cool. So let's say these are the weeks that we have to work with, essentially. And so let me clear this out first. Cool. So 10:7 to 10:23. I want you to be able to at least practice what we talked about today. For the upcoming week, draw things out. What left do you have to do in EPI and grokking?
Sorry, say that again?
What do you have to do in EPI and grokking? Or have you
What
done
do
all
I
of
have
them?
to do?
Yeah, have you finished the book?
I finished grokking the coding one. For the DP one, I only finished like maybe 1 or 2 modules of it.
Okay. I really want you to hammer elements of programming interview because your patterns are very strong. I don't need you to do elements of programming interview. So I want you to focus on EPI. And especially on the strings, what's it called? The strings. So string section.
Okay. You talk about the elements of programming interview?
Yep.
Python book?
Yes,
okay,
correct.
Okay. I have that as well, yeah.
Great. I want you to focus your time on this, especially for the first, I would say the first 6 to 8 chapters. I know like everything up to chapter 4 is like logistics, and then 5, 6. I would say skip the section on XORs, but really I want you to focus on 6, 7, 8, 9.
6, 7, 8, 9. Okay.
Yeah. So if you can this week, it might be a lot, but I think if you do this right and you focus on like what we talked about, I think this will go pretty fast.
Okay.
So I think that's gonna be pretty good for you. So let me go ahead and write these chapters. Now, I don't expect you to do, like, get through all of it. It'd be nice, but I'm going to say, for the most part, you don't need to. You just need to get the idea, get the practice of, like, doing the difference between, like, what they're doing and what you're doing. And once you get that done, like, maybe I would say the first 5 days, everything else will be so super easy. So right now, I want you to, and plus these are, like, the string chapters and array chapters, so this will be right up your alley.
Okay.
And go ahead.
Do you have like any like advice or like preferences in terms of like how I should go through the book? Do I just like kind of read, or like I kind of like read the question, try to do the question, and then look at the answer? Like,
yeah, read the question, do the question, do it pencil and paper, write out your ideas like we talked about, and then when you say you think you're done, and you like think of it this way, it's as if like I made you write it out on pencil and paper, and that whatever you wrote down on there is going to be submitted into the compiler. And if it doesn't compile, you fail the interview.
Okay.
I want you to treat it like that. Like literally, you only get one submission, and if you fail that submission, game over. Okay. I really want you to be super confident in your work before you actually go ahead and look at the answer. And then once you look at the answer, I want you to diff between the solution that they have and the solution you have, but not just that, the steps that you took. And I want you to, for one of the questions, any one that you decide to look at, I want you to record yourself. I want you to record yourself. Like, I would recommend doing it in general, but I want you to record yourself and then go of doing the problem and of going through the whole exercise of like trying to figure out what you did right and what you did wrong. And I want you to talk it out. Like, oh, what did I do here? Like, as if you're having a conversation with yourself. Think you can do that?
Even when I'm doing the walkthrough of like trying to figure out the solution.
Yes, I want you to say all your thoughts. And I want you to get into this habit because that's also like another part. The reason why is because you have a problem with like keep your thoughts in your own head, right? So this is going to kill 2 birds with 1 stone. It's going to help you improve your problem solving and your self-evaluation, and it's also going to get you in the habit of talking your thoughts out. So like if I'm doing something, I'm thinking like, okay, I see I did this step here, but in the book they actually decided to go with this step. Why did they decide to use like a hash map instead of a array here? What benefit does it give, and how could I? And is it reasonable that they did it compared to if I didn't do it? Did I do it better? You know, like having a conversation with yourself and being very self-critical.
Okay.
Yeah, and also like keep a timer so you can say like, oh, I spent too long on this portion as well.
Okay.
This could easily take you like 30 minutes to do, so I would be very patient with the process. Anyway, your daily schedule next. I would say let's say what time do you get to work, and what are your other obligations?
As of now, for weekdays, Monday to Thursday, I try to keep it pretty open, so I have work from like 9 to like I sometimes have to work overtime, so I would say I would just put 6 or 6:30 as like the general time I get off.
Fine, perfect.
Okay. Yeah, I don't have any obligations right now, Monday to Thursday, and then Friday night I do have dance practice from like 7 to 9.
Okay.
But I don't typically hang out after that. I just kind of just go home to hang
Okay,
by
that's
myself.
fine. That's fine.
And then weekends, I generally like try to keep my weekends open right now as well. So I don't have any plans at all during the weekends because I'm trying to like putting time into this.
Fine. I can work with this. And what time do you go to bed?
Typically like 1:30.
1:30, and then you wake up at 8:30, I assume.
No, I'm still working remotely, so I wake up at 9.
Okay, sure.
Yeah.
I'll just set it to 1 to 9, so you make sure we get the 8 hours.
Okay.
And then this is gonna be your sleep. Fine. Okay. So yeah, I do have a big chunk of work. This gives us approximately 1, 2, 3, 4. 2, 3. 3.5 hours on Friday, but then it gives you, we get like a pretty good like 5-6 hours on the weekday. All right, so let's do this. I'm gonna say, wait, what do you do about food? Do you just get food from Facebook or what?
No, like I still work remotely at home, so sometimes I just have food at home. But if anything, I just sometimes go out to get food, like 30 minutes during my work time. I just go out and get some food.
Okay.
Or I have some leftover. Yeah.
What about dinner? Do you cook on your own or?
I live with my dad, so he sometimes cooks, sometimes we sometimes get takeout.
Okay.
Not a lot of time commitments there.
Great. What time do you approximately eat lunch and dinner?
Lunch is about like maybe 12 or 1. Dinner would be around like 7 or 8.
Okay, 7 to 8. I will say let's say 7 to 8 because I want you to spend time with your family too, a little bit.
Okay.
And talk and like so because I feel like, based on my clients, one big thing they always talk about is having this like support structure. So like any of the frustrations that you have with like your coding interviews or your practice or whatever, I think like being able to spend that time talking to your dad about it. He may or may not be a software engineer, but being able to have that conversation I think is important.
Okay.
All right. So then let's say that dinner, I'm going to give you 1.5 hour blocks for work of let's say study. And then I'll give you a 30-minute break, 1.5 hours. And then 1 hour, and then let's say an hour before you go to bed. Yeah, so you basically have an hour off. Yeah, so this would give us 1, 2, 3, 4. This gives us 4 hours a day. And then dance practice, that aligns with your dance practice actually. So then you have an extra pocket of 30 minutes here to get food on dinner Friday night.
Okay.
So that this works out pretty well. I'm a big fan of consistency, if you can't tell. So, like having a very similar schedule Monday through Friday is very, very important. And then so let's say like there's a weekend schedule. Let's keep it the same. Let's say your lunch is at 12 to 1. And then let's say your study time, keep it the same, just so we get a routine. Say, do you have like any like random plans that I should be aware of for the weekends?
I typically like it's very ad hoc, so it's kind of hard to say. Like sometimes I go out to get lunch with friends, or sometimes I just like to go out during the afternoon to go to a coffee shop. So it's pretty ad hoc. So I would say it's definitely adjustable depending on like what you end up wanting to schedule.
So let's do this.
Okay.
Let's say that this 2-hour block is going to be for study. Give you 30 minutes, and then usually lunch is going to be like 12:30. So let's do this. Actually, hold up. I'll give 30-minute break here.
If anything, I like to wake up a little earlier on weekends. But I don't mind like putting in more work.
It's the problem. My problem is that I'm trying to balance your burnouts as well, because I think one of the issues is that if people work way too much, then they can end up burning out. So I'm going to give you this 12 to like 3:30 as potential friend time or whatever you want. But if you want to go for like the extra work, go ahead.
Okay.
And then here, let's do another study here for an hour and a half. And if you feel like you need to go, you need to skip some of the breaks, feel free to.
Okay.
So I'm going to give this like your 4-hour free time on the weekend. So let's call this. This is. Okay. But I would say like if you can try to you can squeeze in some more studying in there.
Okay.
And yeah, okay. So then we'll call this a break time. Hour and a half. Boom. So you basically on the weekend you're gonna be basically nonstop studying, but I do want you to take these like 30-minute to hour breaks if you can.
Okay.
And if you feel like you need to skip them, especially like I'm going super hard or whatever, you can always merge these study times together. But this is like
Okay.
generally what I would want you to at least try to stick to.
Okay. For sure.
All right. Is there any other things I should be aware of? Like anything that might frequently...
Yeah, I think this is fine. The only thing is the 31st to the 6th week. I'm actually gonna be in Chicago. Like I planned this like a few months ago, so
Okay.
it's kind of hard to not do this. I'm taking Wednesday to Friday off,
That's fine.
and I'll be in Chicago with my girlfriend. But Monday, Tuesday, I'm working, so I do still plan to put in study. I still plan to study that week, but maybe I won't be able to put in as much time or commitment.
Okay, so you have 10:31 to 11:06 is vacation, correct?
Yeah.
Okay. Let me see. So this is gonna be 10:31 to 11:06. Okay, vacation. All right. So you're not gonna put that much in, but can you at least study on the plane a little bit?
Oh yeah, that's
Good.
fine.
Good.
Yeah.
So I'm gonna say, yeah, I know how to get on vacation. If that's the case, then let's see. We might want to push this target date to 10:13 for the phone screen. I want you to at least get like 3 weeks of practice with me before we go for the phone screen.
Okay. Because I gave her the dates and times already, so I'm not sure if I could push that again.
Just say, hey, something came up, for that one day, and I was like messaging you like, what? It's only gonna be moved to like freaking like 11:14 or something, right? That's within the second week.
Okay.
So let's just say 11:14. This would give us 3 weeks for the coding, and then they'll give us 3 sessions for system design. That's a little short on time, but I'm really crossing my fingers that we make a lot of progress with before you go on vacation. I really need this. I really need this to happen.
Okay.
So I need you to be like you might want to consider revoking your free friend time as well if it comes down to it. And
No, yeah, like the next 2 weeks are gonna be like pretty focused. I don't plan to do anything extra.
Okay. Let me put the vacation in. Okay. And then that's fine. All right. That should do it. And then I'll try to target. I'll mix in some system design here. So.
Okay.
Because that's going to be a very big doozy. But also, if you can on your vacation, like before you go to bed, like maybe 30 minutes, start reading DDIA. And the chapters I want you to focus on. Let me pull out the book.
Okay.
This is like upcoming, and if you want to sprinkle it for bedtime reading right now, and so you get your feet warm in it, I think that's a good idea. So let me go ahead and let me give you the chapters. I don't want you to do query languages, store and retrieval, compression. I don't need you to do databases. Encoding, no. Yeah, I would say section 2, chapters 5 through. Yeah, chapters 5 through 9 are pretty much your core. So that's gonna be about, and this is not easy to read. Like GDI is not easy to read. So I'd recommend you bite at it like 10 pages at a time. So feel free to start this whenever you want to, but I would highly recommend at least for this week, leading up to Thursday, you focus on like what we're talking about, and then on the weekend, if you find yourself with some free time and you need to decompress a little bit, DDIA is gonna be good.
Okay, I'm just gonna find the PDF online then.
Yeah, you can get Google Books for it if you need. Yeah.
Okay.
Okay. Anyway, so then with that, we're at time. Any final questions about this schedule that we have going?
Yeah, I see at the bottom you say we call every day at 10:30.
Okay, that's an old one. We
Oh,
already
okay.
we've already got our schedule checking. I think
Yeah,
Thursday 8 p.m. anyway. So
yeah.
I've already sent you the schedule.
Okay, yeah, yeah, I see that.
All right. Anything else you need to ask?
Does the EPI section still apply? So I would just do C0 and C1 in actual
Oh,
Python code and then the rest in pseudo, or
I
I
mean,
would.
you can do this. I think when I wrote this was like a sample, but I would
Okay,
say that at the beginning of let me actually open up the book for a hot second. Um,
okay.
uh, Elements of programming interview. Okay, so let me open this up. So there's like a little section at the beginning that would give you like the calendar of like problems that they recommend. So I don't know if you can see my screen, but here, let me show you what I'm talking about.
Are you sharing it
Yeah, let
on?
me show my screen right now.
Oh, okay.
Can you see this?
Yeah, I see it.
Yeah. So it's like this one. Um, this is the section that we're going to talk about. So let me go ahead and open this up a little bit more. Okay, it's this one. So this here is going to be like your 3-day hackathon if you have only 3 days. Really, we're looking at somewhere between scenario 3 and scenario 4, right? So
Okay.
if you read these, you'll notice that hey, yeah, you need to do all these problems and then like maybe like try the pseudocode for these problems. I think that that's going to fit very well, and
Okay.
I would say that even at your level, I think that you can get away with just doing the pseudocode for all of it. But at least for the first few problems that you do, just do it in
Okay.
depth, do it with the code itself, and then once you feel like you got the
Okay.
hang of it, you can probably just like start going for the pseudocode. So,
Okay. Okay.
all right, okay. Anything else?
No, I don't think I have any other questions. It's
All
pretty
right.
clear.
Cool. Yeah. So hopefully you found this session useful. Hopefully you're like you got a lot out of it, and you feel like really amped to like fix your mistakes and do well.
Yeah, no, it was actually pretty insightful because I did a mock interview with my coworker last week, and even though like I did it well, she had the same feedback. But the way she said it was like I didn't really do much in the verification step.
Hmm.
Uh, so yeah, this was helpful.
I mean, they're here. They're trying to be as professional as possible about it, and I don't give a flying fuck, you know.
Yeah.
So, all right. Yeah. Take care. Check in on Thursday. Message me if
Okay.
you have any
All right.
questions. I'm
All
on
right.
Discord, and hopefully you are too.
Yeah, I'm in the server. All right.
Great.
Talk to you on Thursday if
Talk to you
anything else.
later.
Bye.
All right. Yeah. So that was that. Let me go ahead and see where you guys are at. All right. Any other questions from the stream? I guess. Because you know, I'm all ears. If anyone has any questions, comments, feedbacks, and about the session that I just did, feel free to ask right now. If not, then I'll just like stop the stream and just like go get dinner, man. Oh, guess not. All right. Guess there's no questions. So, all right. Thanks for watching, guys. Thanks for supporting the stream. This guy, we will have another stream tomorrow with a different person. And we will have a stream on Thursday with this guy. We'll call him K for now. But K will be giving us a replay analysis for us to look at, reviewing his mistakes and reviewing his problem solving. And we will be looking at that and seeing if we can help him along and hopefully improve his coding ability. So with that, thanks for watching, guys, and have a good night.